Welcome to our pitch about the digital smell sensor. Since the theme of this format is how to transfer science to business, I'd like to start with our scientific work. So please take a deep breath and inhale. The unique smell that you're currently experiencing is a combination of hundreds of different small molecules. We actually want to create an electronic nose that can quickly analyze this smell. Because think about it, we have 5 sensors, but only 3 of them have been commercialized and even combined into one product. But the realization of smell and taste still remains a huge challenge. Why? Well, instead of dealing with easier to mimic mechano or photoreceptors, you need chemoreceptors for realizing smell and taste. And a chemoreceptor is able to sense entire molecules rather than just photons or pressure and convert them into an electronic signal. So when you smell, you inhale small airborne odorant molecules that travel into your nasal cavity, where they are then transferred into an aqueous environment called the mucosa, which contains the specific olfactory cells. Upon proper recognition, an electrical signal is generated and travels to your brain, where the specific pattern of this signal is decoded and tells you what you're smelling. In order to turn this extremely complex process into a technical device, we turn to a chemoresistor device using tailor-made organic semiconductors. Exposure to different odors changes the electronic properties of the different types of conductive materials, thus generating a unique pattern which very much resembles the combinatorial code of our own olfactory system. So we have created a first prototype with this technology using 4 different sensing elements for detecting ammonia and humidity. In the case of ammonia, concentrations down to the 1 ppm regime are possible. In our ongoing work, we expand the number of tested analytes and sensor materials as illustrated in our preliminary heat map. As you can see, isopropanol generates a completely different response pattern as acetone, for example. But we are not just using novel materials, but also a novel pneumatic printing technique to fine-tune device performance. By varying the printing speed, we can control crisp growth, which in turn can boost device performance by up to 3 orders of magnitude. Moreover, this technique allows us to produce fully flexible, fully printed, and therefore very cost-efficient sensors. But now let's switch gears a little bit and talk about waste management. For the last 70 years, trucks picked up the waste in regular intervals, regardless of the fill level, waste composition, or customer needs. Together with our innovative IoT partner Slog, our smell solution offers a more holistic approach. Slog sensors allow to monitor fill level and use 5G technology to realize optimized pickup routes, while AIT smell sensors can determine the composition in the container ahead of pickup and check for contaminations, for example. Like, is there bio-waste in the plastic container or so? Why is this so important? Well, you have to know that more than 50% of the waste that ends up in the residual waste bin is a miss. And this is not only a huge waste of resources, but actually increases recycling costs. Given the fact that in Austria we have about 3.9 million private and another 250,000 industrial waste bins, there is an enormous potential for optimization. Estimates assume a saving potential of about 3.4 million euros annually for communities with a population of about 25,000 people. The immediate benefit of the smart waste bins are manifold and range from reduced CO2 emissions to cleaner cities to a new on-demand waste service that better addresses customer needs. But the Smell project also contributes on a much broader scale to societal challenges, such as raising awareness of waste separation and incentives for recycling. Scientifically, the development of low-cost digital smell sensors is very challenging. We address this issue of sensor drift using a novel optoelectronic concept. We want to contribute to bringing the waste management into the digital age and help protecting the environment by reducing CO2 emissions and create a solution for a more sustainable use of resources. At its core, the Smell project is all about digitization on different levels. And we want to do this now because we believe that the digitization of the waste industry bears a huge potential. And increased environmental awareness of customer also requires a more sustainable solution and smart ideas. AIT is at the forefront of biomimetic smell sensing. And combining this with the industrial IoT expertise of Slog, we can provide solutions for the digital challenges of tomorrow. Please check out more of our biomimetic smell sensing projects on YouTube. Thank you very much for your attention.